This video is for Nova Online Math 161 and we are reviewing for the final exam. The topic that we're looking at is writing functions given zeros. Write a fourth degree polynomial with zeros 5i, -2, and 3. Now, if it's a fourth degree polynomial, it must have 4 zeros. Look, they gave us 1, 2, 3 zeros. So we must figure out what the fourth one must be. Okay? Now look at these 3 zeros they gave us. The first one is a non-real zero with this I right there. So what we can use is the conjugate zeros theorem that if 5i is a zero, then its conjugate pair, -5i, must also be the zero of this polynomial. So by just making the opposite sign, 5i and -5i, we figured out the fourth zero. Now this conjugate zeros theorem does not apply to real numbers. For example, just because you have -2, it does not mean 2, the positive 2 will be the opposite zero. Okay, just because we have +3, it does not mean -3 will be the zero of this polynomial. So this conjugate zeros theorem only applies to non-real zeros, the ones with i's. Okay, so now we got 4 zeros. Let us write the polynomial. I'm gonna just call it f of x. Okay, a common function name f of x. And whenever you're writing the factored form from zeros, it's always going to be x minus. It's always going to be x minus that zero value, okay? X minus c. So I will start by this positive 5i first. So the first factor will be x minus 5i. Next factor, I'm going to use this -5i. That will give me x minus -5i, but double negative, subtracting a negative number will make it positive. So that's why my second factor is x plus 5i. Moving on to -2. So remember, these are going to be opposite. When you see -2 as a zero, the factor better be x plus 2. Because opposites make zeros. That last one, if you have +3 as the zero, then the factor must be x minus 3. Well, that is a polynomial. So I'm thinking maybe can I stop it there? But well, just in case, do we have to continue to simplify? Let's go ahead and try to simplify this to get a standard fourth degree form, okay? So I'm going to start by foiling these first two. The red times red, okay? We will get x squared and then what? X times 5i, that is plus 5ix. But when I multiply the two inner terms, -5i and x, that will give us -5ix. So these two I terms will actually cancel out. Now last one, I want you to look at these two. I have to multiply -5i with +5i, okay? And that is plus 25. Now why though? Okay, let me explain this on the side over here. Okay, when you are multiplying -5i and +5i, well, first of all, if you multiply the numbers, -5 times +5 will give you -25, right? But next, when you multiply I times I, what's that going to be? I squared, right? So let's try to simplify this now. But what's I? Okay, what is I? Now guys, I is square root of -1. So what we are doing is we're squaring square root of -1. Okay? So what happened to this square root house and this exponent of 2? They cancel right out. So what you end up having is -25 times what? -1. And that's why when you do negative times negative, that will turn into +25. So that's a little why behind it, okay? erase this and I'll go back. But I just wanted to show you why negative 5i times positive 5i is positive 25, okay? I think I'm going to go ahead and FOIL the orange and the green now, okay, these two. X times x squared, x times negative 3, negative 3x, 2 times x plus 2x, and finally 2 times negative 3, negative 6. All right, so I have two long factors that I will try to simplify first. So I'm looking at x squared, but notice these two. These two are opposite terms. They are the same, but with opposite signs. So these two actually cancel right out. So the only thing that I have left in the red parenthesis is x squared plus 25. Now, let's get the next one. So I have x squared there. Let's combine these two like terms. Negative 3x plus 2x is negative 1x. And we write this minus 6. So we now have to just multiply this binomial times trinomial. You saw me foiling twice already, so let me try something a little different. I'm going to try to draw a box for this. I like to organize my multiplication whenever I'm working with trinomials. I will put the x squared on the side and positive 25 underneath it. Okay, now on top of these squares, let me write x squared minus x and minus 6. And in the first box right here, I am multiplying x squared by x squared. And that will give us x to the 4th power. So I have x to the 4th power here. Next, I'm multiplying negative x by x squared. That is negative x to the 3rd power. Negative x to the 3rd power. Next box, I'm multiplying negative 6 times x squared. That is negative 6x squared. Go to the bottom. Similarly, I will get these 25x squared minus 25x, and lastly, I may need a calculator for that last part. So for that last part, I am doing 25 times negative 6, and that comes out to be negative 150. Negative 150. Now, let me combine some like terms here if we can find some. Now, I'm going to write out my final answer. So here's f of x. The biggest exponent looks like x to the 4th power. So I'll write that down first. X to the 4th power. Next, this one's next. Negative x to the 3rd power. No like terms so far, but the next terms, these two. Negative 6x squared and positive 25x squared. When you combine them, you're going to get plus 19x squared. And the other two. This one doesn't have any like terms. I'll write down minus 25x. And this last number, minus 150, no like terms, so just write down negative 150. So, writing the polynomial itself was just not much. But we did spend some time simplifying this polynomial all the way down to a standard form. But remember, the important theorem that you have to remember is called the conjugate zeros theorem, that when you have 5i as a 0, then negative 5i, its conjugate pair, is also the 0 of that polynomial.